Mungu ibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.
Reform 60 or from 60 students who has been looking at online school where you can learn basic mathematics at anywhere and anytime. Or are you a Form 60 student who is pursuing either PCB or CBG or CBN or CBA or ECA or HGE and have been looking at online school that can teach you the beauty of basic applied mathematics from 5 and from 60? So, or are you a parent who have a son or a daughter who is pursuing either of these 6 combinations and then you have discovered he or she is not performing well in basic applied mathematics, so you have been looking at help online at any time and anywhere? So the answer of all those questions will be revealed in these sessions. So I ask you to stay tuned. How are you, everybody who is watching this video? I would like to take this opportunity to welcome all our national and international students to enjoy the beauty of basic applied mathematics. My name is Olenjolai. I thank God by His own grace who has given me His gift of teaching, and I thank God who have given me a citizenship of the kingdom of heaven. And I thank God who have given me citizenship of Tanzania. And I thank God who have given me a true love of advanced pure mathematics. So I would like to take this opportunity to welcome you and let us join me in this moment of opening prayer or alpha prayer. Our Father who is in heaven, we come before your presence. We thank you for your greatness. We thank you because you're wonderfully and grateful, Father. We give you all the praise and all the honor. Father, we thank you. Welcome into this session. We repent for all our sins, for all our transgressions, for all our iniquities. Welcome to help me to teach your students the beauty of basic applied mathematics now and forever. Father, we thank you for your beautiful name, and we thank you because you are in our midst, and welcome to help us to understand and learn this concept in the name of Jesus Christ. Amen. Thank you very much. So let's take this opportunity, secondly, to welcome you into our Tanzania Online Advanced Secondary School in square bracket Olenjolai. So continuously welcome into our official YouTube channel that called Tanzania Online Advanced School in square bracket Olenjolai. Welcome into departments of advanced mathematics and welcome in the subject called basic applied mathematics. And today I'm teaching you the set chapter that called exponential and logarithmic function, or the subject today is called basic applied mathematics. And I dedicate these contents to all pre-Form 6 students, Form 6 students, QT, reciters, grade 11, Form 5 students who are pursuing either of this combination, PCB, CBG, CBN, CBA, ECA, and HGE. So all of these 6 combinations, they have to pursue the beauty of basic applied mathematics. If you are first time, you are welcome. And then we ask you to click the buttons of subscribe in order for you to receive notification or whenever we upload or publish a new video for you. So in case you have any question about session 6, which is titled as solving problems of derivatives of exponential function, then don't hesitate to ask in the comment sections of this video. The prerequisite of session 6 is actually session 5, where we have introduced you the concept of derivative of exponential function. So let us start our today's session straightforward, the quick review of session Session 5. This session is titled as Intro of Introduction of 40 Introductions of Derivative. Derivatives of exponential function. So introductions of derivatives of exponential function. So simply we told you that if you differentiate d dx of e of x, the answer is equal to e power x. And also we told you if you differentiate d dx of a power x, this is equal to what? It's equal to a constant k, a of x, yes, so it's equal to constant k, a of x, and then we taught you if you differentiate by using chain rule e of f of x, then this is equal to f of x dash, then e power f of x. And we left the homework, which actually was example B, for example A, which you can call the example 12. So today we'll be focused on problem solving, and here it is, example 12. So example 12, refer to the book called Basic Applied Mathematics for Advanced Level Secondary School for 5 and 6. So the question here, which has 4 Romans, and the question is one of the examples. Find the derivative derivative of the following. Find the derivatives of the following. A f of x is equal to e power 2x plus 3. And then on B, g of x is equal to e power 1 minus x squared, and C have h of x, it's e plus 3x. So A, B, C, D, Roman D, g of x is equal to e power 3 minus 3, no, minus 2x. Minus 2x. So find the derivatives of the following exponential function. All of the given exponential functions are natural exponential functions. So I'll be solving some of them because all of them are just by using the chain rule. Because this exponential function power means that is exponential function, the base is e, and the exponential function is what? It's quadratic in some of the questions and linear. So solution, you can pause the video and try to solve example 12. No, this is example 13 because example 12, it is example A. Think that example A or B, something like that. So solution. So the first step, let us start with the example 13 Roman A. So f of x is equal to e power 2x plus 3. So the first step, we say that let u is equal to 2x plus 3. So then find the u dx. So this is d dx of 2x plus 3. So then I have what? The u dx. So if you differentiate 2x plus 3, differentiate 2x with respect to x is equal to 2. If you differentiate 3 with respect to x is equal to, simply it means that this is equal to d dx of 2x plus d dx of 3. Okay? So simply this is 2 plus 0, because if you differentiate 3, you get 0. So the u dx is equal to 2. So the u dx is equal to 2, and this will be equation 2. While this one will be equation 1. So remember that the second step, let us find the, okay, simply it means that let us find dy du. So from the given function, remember that f of x is equal to y is equal to e, but you have let 2x plus 3 is equal to u. So e by u. So y is equal to e by u. So find the y with respect to u. This is equal to d du of e by u. So if you differentiate e by u, you get e by u. So dy du is equal to e by u. And what is u? Is 2x plus 3. So dy du is equal to a power 2x plus 3. So this is equation 7. So the third step, called the chain rule. So the chain rule, we say that dy dx is equal to du dx multiplied by dy du. So so simply dy, derivatives of y with respect to x, is equal to du dx. What is du dx? So du dx it is 2. Then what? Dy du. What's dy du? Dy du it is e power 2x plus 3. So this is equal to 2a or 2x plus what? Plus 3. So we've been asked to find the derivative of that function. So what's y? Y it is e power 2x plus 3. So out of a d dx of what? Of a power 2x plus 3 is equal to 2e by 2x plus 3. That's the response. Okay, so let us solve again the function of g of x, which you have to remember is equal to y, is equal to e power 1 minus x squared. So the problem we have to solve by using only the chain rule. That's how, not the technique. You can pause the video and try to solve it yourself. So simply you can say that y is equal to e power 1 minus x squared. This is equation 1. So the first step, we can let u is equal to 1 minus x squared. So the u dx is equal to d dx of 1 minus x squared. And this is equal to d dx of 1 minus d dx of x squared. So the u dx is equal to, if you differentiate constant to 1, it is 0, minus differentiate x squared, you get to x power 1. So this is equal to negative 2x. So simply the u dx is equal to negative 2x. You can call this one equation 2. Second step. Let us find dy du. Dy du. From what? Dy du from y is equal to e by u. So dy du is equal to e by u. If you differentiate e by u, you get e by u. So what is u? U, it is 1 minus x squared. So this will be equation 3. So you can substitute equation 3 into the chain. Alternatively, we can do this. First, the steady state, we call the chain rule. dy dx is equal to du dx times dy du. And this will make equation what? Equation 4. The first step. Substitute equation 1, equation 2, and the equation 3 in equation 4. So dy dx is equal to the u dx. What is the u dx? U dx is negative 2x. So it's negative 2x. We have the u, dy du. dy du is e power 1 minus x squared. So therefore, d dx of what? Of a power 1 minus x squared is equal to what? Is equal to negative 2 x e power 1 minus x squared. That's the response. So for that case, now example 13C and example 13G are your homework. So this is your homework 6, and this also will be your homework 6. Okay, that's all about example 13. Now let me present to you example 14. And this example 14, you have to refer from a book called Basic Applied Mathematics. Basic Applied Mathematics for A level, second score, exercise 9.20. 9.3. Question 1. Find the derivatives of the following. Find the derivative of the following. Roman A f of x is equal to b plus square root of x. Roman b h of x is equal to e of 3x minus 4. This will be your homework 6. And Roman C, g of x is equal to a power under root of x plus 3x squared. Solution. Find the derivatives of the following. Roman A f of x is equal to e power square root of x. Roman b h of x is equal to e power 3x minus 4. And this is your homework. And Roman c is g of x is equal to e power square root of x plus 3x squared. So let us start with this one. So solution. So Roman A, the function f of x, which is equal to y, is equal to e power under root x. So let this as question 1. Then the first step, have let usual. So let u is equal to square root of x. In other words, square root of x is equal to x power a half. So find derivative of u with respect to x. Simply this is equal to differentiate d dx of x power a half. So this will make what? So remember the rule that if you're differentiating d dx of x power n, this is equal to what? N x power n minus 1. So this is our n. So here the response will be what? A half. Then x, so this is x power a half minus 1. Here it is what? Du dx is equal to what? Is equal to a half x power negative a half. So in other words, okay, so this will be question 2. So y is equal to e power u. So at the second step, let us find that. Let's find dy du. So dy du is equal to what? Is equal to d du of e power u. So the answer is e power u. So dy du is equal to e power u, and this is question 3. So the third step we call chain rule. So to recall the chain rule can help us to find dy dx, which in other way is equal to d dx of what? Of f of x, and this will be equal to dy times du, then multiplied by what? Du dx. And this will be question what? Question 4. So the first and last stage, we can say that now substitute question 2 and question 3 and question 4 above. So dy dx is equal to du dx is a half x power negative a half multiplied by dy du, which is e power u. If you simplify this, 1 a half times x power negative a half is equal to 2 under root of x. It means that x power negative a half is equal to 1 over under root of x, then multiplied by e, and what is u? U, it is under root of x. So we let u is equal to under root of what? Under root of x. So therefore, the answer for 1a, it is dy. So we've been asked to find the derivatives of, so dy d dx of e power under root of x is equal to e power under root of x divided by 2 under root of x. 2 times under root of x. Now the response for example 14, Roman A. Okay, so let us solve for example 14, Roman C. Roman C. So we have been given g of x is equal to 1 is equal to e power under root of x plus 3 x squared. The first step, say let u is equal to under root of x plus 3 x squared. So here we have the u dx of what? D dx of under root of x plus 3 x squared. So the u dx is equal to d dx of under root of x plus d dx of 3x squared. So you can pause the video and try to solve it yourself. Okay? So here we have the u dx. Remember that this is equation 1. The u dx, if you differentiate the square root of x, so you know the response will be this. So it will be a half, x power negative a half. Simply this is 1 over 2 under root of x. So this is equation 2. Okay, wait a moment. So we left another particular sort. If you differentiate 3x squared, so these two comes here to be plus 6 x power 2 minus 1. So the u dx is equal to 1 over 2 square root of x. That's what? Plus 6x. Plus 6x power 1. This is equation 2. Second step, from y is equal to e power u, let us find dy du. So dy du is equal to e power u. If you differentiate e power u, you get e power u. So this is equation 3. So steady state. Let us substitute equation 2 into 3 in chain. So remember the chain rule. So chain rule, say dy dx is equal to dy du times du dx. So d dx of e, or under root of x, plus 3 x squared is equal to dy du, or du dx, which it is 1 over 2 under root of x plus 6x times e power u, which is e power under root of x plus what? 3 x squared. This is the response of example 14. Example 14. So the example 14. So ladies and gentlemen, get prepared for example 15. Keep enjoying the beauty of basic applied mathematics and the beauty of exponential function and logarithmic function, but especially derivatives of exponential function. So stay tuned, enjoy. Okay, so let us continue with this fantastic session 6 that titled are solving problems of derivatives of exponential function. So we are done with example 14. I believe that you have got concepts that have been insisting you on how you can solve about this problem. So regardless whether you're PCB or you CBG students or CBN students or CBA students or ECA students or HGE students or international students, I believe that when we've been solving together example 14, you have enjoyed. So allow me just to present to you example 15, which is also still come from exercise 9.3 of this interesting or this excellent book according to the syllabus of United Republic of Tanzania that called the Basic Applied Mathematics for Advanced Level Secondary School Students Books for the Form 5 and Form 16 by Tanzania Institute of Education. So are you ready for example 15? Remember that I'm using the method, or we use the method that we call it active learning system. So once I've written example 15, you are allowed to pause or to stop the video and then try to solve example 15 on your rough paper. Once you are done, then you compare your solution or your trial solutions or your trial solution with the solution that I will teach you. So once you are done, you can click the buttons of play, continue watching the solutions and how we can solve example 15, and then you'll be correcting yourself about some mistake that you've done or maybe some confusion that you've encountered when you've been trying yourself. That the method I've used myself to learn advanced pure mathematics, basic applied mathematics, and even basic mathematics when I was in ordinary, and even engineering, higher engineering mathematics in engineering programs. So are you ready for example 15? Okay. Let me present you. So example 15, simply say that refer basic, means refer basic apply basic applied mathematics Basic Applied Mathematics book by Tanzania Institute of Education in exercise 9.3, and I would like to solve with you question number 2 in this exercise, which has been left for students to solve himself or herself, but myself, because I would like to see all my online students understanding the beauty of basic applied mathematics. So I would like to give you a way that you have to solve exercise 9.3, or you have to solve different problems about derivatives of exponential functions. So here is the question, and you can find it in page 281 of this book. So the question states that determine the derivative. Determine the derivative of the following. Determine the derivative of the following functions. Determine the derivatives of the following function at the given value. At the given value of what? Of x. So we'll be given also Roman A to Roman C. I'll be solving to Roman A and Roman B. No, I'll be just solving Roman A. Yeah, so you can try Roman B and C. Okay, so Roman A, is the function is f of x is equal to x squared e power 4x. E power 4x. So this we call the composite function. Okay? But today we have to find the derivative of this function at x is equal to 1 over 4. And then Roman B will be given another function, f of x is equal to e power x plus square root of x, at x is equal to 4. At x is equal to 4. At x is equal to 4. So if you have pre-form 6 student or a form 6 student in either of these 6 combinations, I believe that right now you are giving God thanks for the great thing, or for the great information that you are receiving in your mind. And Roman C, like you say, excuse me, this is not f of x, the function is called the g of x. Then Roman C, ladies and gentlemen, we have another function which we call the h of x. And this h of x, it is x times e power x squared. Or x squared. At t, x is equal to 1 over 4. No, 1 at x is equal to negative 1 over 5. Negative 1 over 5. So ladies and gentlemen, that is all about example 15. So you have to refer to the book that I've mentioned to you and I've presented to you. So the question states that determine the derivative of the following function at the given value of x. So Roman A, f of x is equal to x squared times e power 4x at x is equal to 1 over 4. And Roman B, g of x is equal to e power x plus square root of x at x is equal to 4. And Roman C, h of x is equal to x e power x at x is equal to negative 1 over 5. Okay, so in Basic applied mathematics for the Form 5, which actually was the first subject that we taught our basic applied our Form 5. It's the second. So remember chapter 2 of the subject called Basic Applied Mathematics for the Form 5, which is called the functions. So we taught you different types of the functions. So this is actually it is a composite exponential function. Why? Because this is a common exponential function, and this is what exponential, natural exponential function. This is a natural exponential function, and this one is composite exponential function. What it means of composite function? Composite function is any function made composed by more than one function. By more than one function. You have differentiate composite function from step function. We have also we call them just logarithmic functions. So we have different types of the functions, but we can have also composite function, which actually we call it a compound function. So it's a function made by different functions. So, ladies and gentlemen, solution for example 15. So the best solution for example 15, we have Roman A, Roman B, and Roman C. So I'll just do Roman A, and then you will do Roman B as your homework and Roman C as your homework. Because the way that I differentiated the given function in example 14A, B, I think that B left it, or in example 14C, is the same way you'll be using to differentiate this exponential function. And then I'll teach you what are you going to do with the given value of x. The way I'm going to differentiate this exponential function, f of x, exponential function, and substitute the value of x, it's the same way that you'll be using to differentiate this function. Because this is the composite exponential function, this is also composite exponential function. Why? Because this is common exponential function and this is natural exponential function. You can have also a composite function which is made by logarithmic function and the exponential function. You can have also a composite function which is made by step function, rational function, and the exponential function. So we have different types of composite function. So ladies and gentlemen, solution, and then let us start with Roman A. So in Roman A, we'll be given a function which is f of x is equal to x squared, because that a challenging function compared to others. Okay, so f of x is equal to x squared, and hence I'll be given at x is equal to 1 over 4. 1 over 4, yes. So we'll be following steps as usual. So the first step, we say that, so the first step, okay, so the first step we say that we are given a composite, a product, so we are given what composite exponential function, or simply we'll be given a product of 40, which is product of two exponential function. That's the very important point. So if this is all about analysis of the given function, f of x is equal to x squared, then you have e power 4x. So how can we deal with this function? Okay, so we have to let, so remember that this is equal to 1. Okay, so we have to let, this is the product of two exponential functions, common exponential function, natural exponential function. So you have to let u is equal to x squared, and also we have to let v is equal to what? E power 4x. Why? Because these are the two different exponential functions. Okay? So once we've let these two functions, we have to go into the second step. So the second step, we say that differentiate what? Find what? So let us find the u dx and the dy dx, or dv dx. Okay, so we say that dy dx, let us differentiate our function u, which is x squared. So this is equal to d dx of x squared. Then you're using power rule, right? So power rule means that we say this, the exponents, which is 2, will become as coefficient, and then here we have x power 2 minus 1. Okay, then you take the exponent minus 1. So then the answer will be 2x. So it means that, this is the du dx. So simply we say that du dx. So suppose that this is the first question. So the u dx is equal to 2x, and this is question 2. Then let us find the dv. So dv dx, this is equal to d dx of given natural exponential function, which is e power 4x. And this is equal to what? So you remember that we have to let what in? We have to let this exponential function. Okay? So you have to let this exponential function, if just will go slowly with you. So you remember that how I've taught you. But let me just still taking care for you. So differentiate this function, we can also let what? Can let a is equal to 4x. So for that case, v now is equal to e power a. So you have to find derivative. We have to differentiate a with respect to x and differentiate v with respect to a. Then we have to use what? Chain rule. You have to use the chain rule to get the derivative of y with respect to x. I believe that you're enjoying the beauty of basic applied mathematics regardless of your bad background. So for this case, let us find the a dx. Let us differentiate a with respect to x. So our function is 4x. So this is equal to d dx of 4x. And these are the take constant out. It is d dx of 40 of x power 1. This is the exponential function. So we take exponent 1 times 4, which is 4. And then say of x power 1 minus 1. So ladies and gentlemen, dA dx is equal to what? Is equal to 4 times x power 0. This is 4. Again, we have what? We have our function which is v is equal to a. No, e power a. So for that case, the v dA, this is equal to what? d dA of exponential function e power a. If you differentiate e power a or e power variable and a variable, you get e power a. Okay? So for that case, we say that the v dA is equal to e power t, e power a. So this is the steady state. Steady state. Right, the steady state in the second state. So the first state, so you say that recall what? Recall chain rule. So to recall chain rule, we say that d, so you're looking for dv with respect to x. dv dx, this is equal to, will be equal to dA times dx for this particular function. dA dx over dx, no, okay, times what? dv dA. So chain rule, always this and this will cancel. So what is dA dx? dA dx is equal to 4. We found 4. What is dv dA? It is e power a. What is the value of a? So a we are given as what? 4x. So simply dv dx, derivative of v with respect to x, ladies and gentlemen, is equal to 4 e power 4x. This is equation 3. So now we have du dx, we have dv dx, but we didn't. In the question we're being asked to find dy dx. So remember that du dx is not dy dx, and dv dx is not dy dx. So we have to keep working. So we go into the fifth step. The fifth step, we have to recall another rule that we taught you in differentiation. And this rule, we say that recall product rule. Product rule. So product rule state that if we differentiate, for example, d dx, we are differentiating products of two functions, which is u, function u times function v, products of the two functions u and v, then the response will be what? U dv dx plus v du dx. This is what we taught you in the topic of differentiation during your Form 5 studies. So remember that here we have a composite function. So this is function u and this is function v. So for that case, right now, so you can call this formula as what? So you can call this formula, so you can call this formula, so we had let x, okay. So simply say that, so to find the derivatives of the given function, so you say that now d dx of what? Of the given function, which it is x times e power 4x. 4x. Then this one is equal to u. What is u? We let u is equal to x squared. Then times what? dv dx. We found dv dx is equal to 4 times e power 4x. So this is equal to 4 times e power 4x plus, then we have v. What is v? So v will be given as what? E power 4x. E power 4x. E power 4x. Then we multiply with du dx. Du dx, where is du dx? It is 2x. So du dx is 2x. So here we have what? Here we have d dx. D dx, x, we have x power 4x, and then we have what? So here we have 4x squared times e power 4x. Then plus what? So plus twice x times e power 4x. So ladies and gentlemen, this is the response for example 15 Roman A. Okay? No. This is not the response, excuse me. We have to continue because we have been asked to find the derivative of what? The derivative of x times e power 4x as at what? At x is equal to 1 over 4. So we have to continue. So usually we used to end there. But according to the nature of the questions, we have to go another step further. Are you ready? Okay, another step further. And the next step right now, we have to find the derivative or the slope or the gradient of the given graph of the given exponential function. We call it the gradient of the curve of the products between common exponential function and the natural exponential function. So we have to find a value, because remember that this is the gradient of this exponential function, but at the function. We can find gradient of the given exponential function as an actual value, as a numerical value. Alright, are you ready for that? So we say that now D, so we have to go into the 6th step. So the 6th step, we say that find what? So let us find the gradient of our exponential function xe times e power 4xe at xe is equal to 1 over 4. So what you have to do, so simply you have to say that to find, so it means that you have to say that d dx of x e power 4x at what? At xe is equal to 1 over 4. This is equal to, so whenever we have xe, substitute xe by what? 1 over 4. So it's what? So here we have 4, then here we have x. So instead of x we have 1 over 4 square times e. Here we have 4, 1 over 4. Okay, then plus what? 2 times 1 over 4. Okay. So here you have quarter of e plus a half of e. Okay. So quarter of e plus a half of e. This will make what? This will make 3 over 4 e. E power t power 1. Okay. But we can keep finding the value of what? The actual value or the actual number. So from session 1, we told you, we gave you the value of e, but in case you forgot, you can recall it from your scientific calculator. So the value of e, it is what? 2.71828. Okay. So finally, you'll find that the value, or after your computation, the value, the actual value will be what? So the actual value for this problem is 2.04. So use your scientific calculator, your final value is 2.04. But even if you have 3, or you have 3 quarters times e, that also is a correct response. So now the conclusion for example 15 Roman C. Conclusions of example 15 Roman C. We say that therefore d dx of xe squared times e power 4x x at x is equal to 1 over 4 is what? Is 3 quarters times e power 1 or 2.04. This is your final response. Okay, so you have to do the way that I did the question or exam 15A. So it means that now, so your homework 6. So it means that solve example 15 Roman B and the Roman C. The same way. Once you find the gradient of the function, of the given exponential function, then you have to substitute the given value of x to find the actual value. Alright? Okay, so Roman A and B. So just you have to differentiate. Remember the two steps, the two main steps that you have to follow. The first step, differentiate the given exponential function. And the second step, substitute the given value of x to find the actual value of gradient or slope of the given function. So if that's the case, so please try to do example 15, Roman B and C, and submit your solution in the comment sections of this video. So example 16, ladies and gentlemen. So we have I would like to refer also the same book, refer basically applied, which in short we call it BAM, Basic Applied Mathematics, Basic Applied Mathematics book, okay, by what? By Tanzania Institute of Education, exercise 9 and 3, and let me do question 3. How does it state? So question 3. I believe that you're enjoying the beauty of 14, the beauty of exponential function, the derivatives of exponential function. So again, question number 3, I would like to guide you how you can solve question number 3 because it is exercise. So I have to show you the way. Find the second. So this is concept. So right here, concept. Find the second derivative. Find the second. Read the question read the questions with me. Find the second derivative of the following functions. Roman A, y is equal to e power ax plus b. Roman B, the given function is y is equal to y as dependent variable, 3 times e power 1 plus x squared. Then Roman C, it's y is equal to e power sine of x. So you've been given 3 exponential functions. And the good news that all the 3 exponential functions it is natural exponential, it is natural or common exponential function. The answer is this is natural exponential function. It is natural or common exponential function. The answer, this is what? Natural. This is natural exponential function. It is natural or common exponential function or composite function. The answer is this is a natural exponential function. 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 Okay. So solution. Find the second derivative. So this is very important, or this is the key word for this question. Find the second derivative. Say with me, second derivative. Second derivative. Okay, my dear students, when we've been teaching about coordinate geometry, we've been teaching you how you can find gradient of polynomial function in most cases, or how you can find the gradient of the straight line. Just linear polynomial functions, that's all. That's what we've been teaching you. Because if you find the equations of the given equation of the line, it's actually linear polynomial function. So when we've been teaching you how you find the gradient or slope of linear polynomial function, we used it to find the actual value or the numerical value. Now we are teaching you about the gradients or slopes or derivatives of other functions, of higher functions. right? It can be a polynomial function, but it can be quadratic polynomial function. It can be cubic polynomial function. So what do I want to tell you? If the first derivative of the function is a function, then we can differentiate that gradient to find the second derivative, which is the second slope of the curve. Alright? So remember that always we have higher derivative in mathematics, and this concept of higher derivative is actual that the output of the first derivative or the output of the initial derivative will be the input of the next derivative. For example, the output function of the first derivative will be the function that you'll be using to find the second derivative. Again, it means that the second derivative, the second derivative will be the function that will be used to find the third derivative. And the third derivative or the third gradients of the curve will be the function that will be used to find the first derivative. Okay? So remember the concept we taught you in differentiation. If you've missed it, I want to tell you that we have also a good news. We are also teaching the beauty of basic comparative mathematics for the Form 5. So you can go into our Tanzania Online Advanced Secondary School in square bracket Olenjolai, and especially into official YouTube channel that called Tanzania Online A-Level Circuit School. And you have to remember to subscribe, because we are creating contents every day. And we are creating contents every week for advanced secondary students. So you can review the concepts of higher derivative that I taught you in the, I think that in chapter 5, yeah, is it chapter 5 of basic comparative mathematics, call it the syllabus of United Republic of Tanzania. It's chapter 4. So chapter 4 differentiation. So we had just introduced to you about higher derivative. But in case also you forgot, don't worry, I'm here to remind you. Okay, so we've been asked to find the second derivative of the following function. So the first step. So the first step, you can say that the first step considered. So let us solve example 16 Roman A. So consider this given function, which is y is equal to e power ax plus b. So you can notice that in exercise 9.63, every questions teach you something. Okay, so consider y is equal to e power ax plus what plus b, and this we call the equation 1. So that the first step. So we have numbered the given function. The second step now, we have to find. We have to find what? Let us find derivative dy dx. Okay, dy dx. So how can we find? So we have y, will be given y is equal to e power ax plus b. But remember that a and b are constants. So a and b, these are constants, are not variable. These are constants. Okay? So how can we differentiate this function? We have to let u. It's not necessary to use variable. We have more than one variable that we may let in mathematics. Let u is equal to ax plus b. So then the u dx, this is equal to d dx of what? Of ax plus b. So this is equal to d dx of ax plus what? Plus d dx of b. So simply say that the u dx is equal to what? So a, it is constant, so you can take it out of the function. So d dx of x power 1 plus what? D dx. So you have differentiate constant. And I have told you that if you differentiate constant, let us differentiate x with respect to x. So here we have a, then here our exponent is 1, can become coefficient, x e power 1 minus 1. Simply say that if you differentiate x with respect to x, you get 1. And then plus what? Constant b. If you differentiate constant b, the answer is 0. Then we have du dx is equal to what? So it's equal to a x e power 0 plus 0. So this simply is equal to n. Okay? And then our function now, it is y is equal to e power u. So let us find the y du. The y du, if you differentiate e power u, the answer is e power u. Okay? Then we go into the steady state. So the steady state, ladies and gentlemen, we have to recall what? Chain rule. Chain rule. You have to differentiate this natural exponential function. I believe that you're enjoying the beauty of basic applied mathematics, and I believe that you're enjoying the beauty of exponential function in this session. So if that's the case, we say that, so we have that. So chain rule, so we say that we are looking for dy dx. This is equal to what? This is equal to du dx multiplied by what? Multiplied, this is our chain rule. Multiplied by dy du. So you can find that from this chain rule, you can simplify the u and remain with dy dx. Ladies and gentlemen of pre-form 60 students, okay? So the u dx, it is what? Du dx, it's a, this one. So the u dx is a. Then dy du, it is e power u. But u is actual intermediate function that we let is equal to ax plus b. So simply this is a e power what? Ax plus b. So that is dy dx. So now we have dy dx. We have found dy dx, which means that this is the first derivative of our exponential function of ax plus what? Plus b. So ladies and gentlemen, this is equal to first derivative. First gradient of given exponential function. So you have to go another step further. So the next step, which will be the fourth step, usually we used to say that in previous steps or in previous questions, you say that this is the derivative of the function, it is true. So the fourth step, ladies and gentlemen, according to the question, we've been asked to find what? Second derivative. So find what? So find the second derivative. Second derivative. So let us find the second derivative of y is equal to e power ax plus b. As I said, the function we found in first derivative will be the function that we'll be using to find the second derivative. How do we write, first of all, how do we notate the second derivative in mathematics? We have different notation. So simply the second derivative, we have to differentiate the first derivative. So this d dx of our first derivative there, which is dy dx. Okay, this is the first notation. This also can be written, can write like this one, d square, then dx of 40, d square x of 1. Okay, so d square dx square of 1. And also this can be, we can write in short as what? D square y over dx square. So these are the three common notations of second derivative. But you can also use the f double dash. For example, that we can say that, okay? So let me just give you another first notation. So this we call James notation. So this is equal to second derivative of y, d square y, dx square, and this can be f double dash of x. So simply this is d square y, and then the x is equal to what? So differentiate this. To find the second derivative, we have differentiate the first derivative, which is a e power ax plus b. A, it is common, so we can take it out of the derivative. So simply this is a d dx of a e power ax plus b. No, we don't have this a, excuse me. So you have to differentiate this and multiply with a. Example 16. Okay. So, so if that the case, we could say that, so we want to differentiate this now. So, the first step, you can differentiate it again. Okay, so the first step, we say that we call d dx of what? So consider that this to be, let's say equation 2. d dx of e power ax, we have found in previous steps, is equal to what? Is equal to ae power ax plus b. Or you can find the derivatives of this function is all about what you have done from the first step to the fourth step. So this is dy dx, means that d dx of e power ax plus b is equal to this. But we can do it. We can do it. Okay, we can do it. But just you have to refer. You have to refer. It means that it means that to find out. So it means that simply say that d dx of what? Of e power ax plus b. This is equal to a e power ax plus b, and this is question 3. Because equation 1 always the given function y is equal to e power t, e power ax plus what plus b. So if that's the case, we go into the sixth step. So the sixth step, we can say that substitute equation 3 into equation 2. So let us substitute equation 3 into equation 2. So now the second derivative, d dy x square, which also is equal to d dx of what? So d square x square of y, which it is e power ax plus b, is equal to what? First of all, we have a. So it's equal to a times what? So a times d dx of e power ax plus b, which is equal to a e power ax plus b. So in this case, we say that the second derivative of the given function is equal to what? Is equal to a square e power ax plus b. So this is the second derivative. Okay. So we still have what in order to. So solution of example 16, Roman C. So the function So first step, we have been given the function y is equal to e power sine of what? Power sine of x. So let this one to be our function for our first equation. Okay? So differentiate, this is natural exponential function, but our exponent is sine, which is a trigonometrical function. So it means that this we have numbered our equation. We have to go into the second step. The second step, we have to find out. We have to find the first derivative, dy dx of 14 of equation 1 above. Dy dx of equation 1 above. How can we find it? Firstly, we have to let u is equal to our exponent. U is equal to sine of what? Sine of x. U is equal to sine of x. So we have to find the first derivative of u with respect to x and first derivative of y with respect to u. Then we use the chain rule as how we have done example 16 Roman A. Basic mathematics is beautiful, and exponential and derivatives of exponential function is beautiful concept. So, so if that's the case, we have to find the u dx, which actually is equal to d dx of sine of x. So if we differentiate sine of x, we get cosine of 14 of x. Differentiate sine of x, we get cosine of 14 of x. Differentiate sine, you get cosine of x. Differentiate cosine of x, you get negative sine of 14 of x. Okay? So remember that. Differentiate sine of x, you get cosine of 14 of x. So simply our du dx is equal to cosine of x, not negative cosine of x. Again, we like to find dy du. So dy du simply it is d du of e power u. I'm using u commonly in order to help intermediate, faster, and slow learner students to understand and have common variable in your mind. I can let also v is equal to sine of x. I can let also a is equal to sine of x. I can let also b is equal to sine of x. So I have different choices. So differentiate e power u with respect to u, then we get e power u. Okay? So we go into the steady state. But what is e power u? E power u is e power sine of x. So the steady state, we say that recall the chain rule. So the chain rule can help us to find the y dx of this kind of the function, this type of the function, and this will be what? Du dx times what? dy du. dy du. So du will cancel. So du dx is what? Du dx, it is cos of x. Then dy du, it is what? Dy du, it is e power sine of x. So ladies and gentlemen, dy dx, this is equal to what? This is equal to cosine of x, e power sine of x. But this is the first derivative. Remember that this is first derivative or first gradient. So first order, this is first derivative. The question asks us to find the second derivative of this function, so you have to go one step further. The first step are 2 steps further. Okay? The first step or 3 steps further. Okay, we have to go more steps. Okay, the first step, we have to find it. You have to find the second derivative. So let us find the second derivative. Second derivative. What the notation, the common notation, the second derivative to avoid confusion, dy dx squared. Okay? How can you find? Remember that I taught you the principle. The second derivative of y with respect to x is equal to derivative of first derivative, which is dy dx, like this. So we have to differentiate our first derivative. So it means you have to find d dx of our first derivative, which it is cosine of x times e power sine of x. So now this is the composite function. Composite are trigonometrical function and composite natural exponential function. Okay, so if that's the case, you have to continue. So that's why I've written example 16 is conceptual question. So if that's the case, we may go into the fifth step. The fifth step, we can let v to be our new function, which is cosine of x times e power sine of 40 sine of x. So we have to find the derivative of this. We have to find the derivative of this function. So this is the products of 2 functions. So I think that let p, in order to avoid confusion from you, let p. Let p is equal to cos x times e power sine of 40 of x. Right? So for that case, it means that when we are finding dy dx, right? Simply for this case, it will be equal to this is equal to dp dy dx. Because p is our first derivative, it is gradient of the given curve. So if that's the case, you say that the differentiated function, we can say that this is the products of 2 functions. Let u is equal to cosine of x, and let v is equal to what? Is equal to e power sine of x. Ladies and gentlemen, find the u dx. Differentiate cosine, you get negative sine of 40 of x. Then, ladies and gentlemen, find the v dx. So the v dx is the exponential function. If you differentiate exponential function, so we found the v dx. The v dx, we found it. It's our first derivative of the given function because we found here dy du. So we had the dy dx. It means that simply d of e power sine of x is equal to cosine of x. Then we say what? E sine of what? Of x. The goodness of second derivative, you have something to refer. So the 6th step, we have to recall a rule that we taught you in differentiation. Chapter 4 of basic applied mathematics from 5. So recall what? Recall product. So recall what? Recall product rule. So product rule, we say that dy dx is equal to u dv dx plus what? V du dx. So here we have dy dx, which is equal to what? What is u? U is cos of x. U is cos of x. dv dx here, so what? It's cosine of x, then a sine of x. Afterward, plus, what is the rule? Plus what is v? What is v? V it is e power sine of x times what? Du dx. Du dx. du dx. What is du dx? Du dx is what? Du dx. It's negative sine of x. Okay? But our function today is not p. It's not y. It's what? It's p. Right? So simply say that dp, because our function here is not y, dp d what? dp dx is equal to what? Cosine of x stays with cosine of x. This makes cos square of x. Then what? E power sine of x. Then plus what? Plus e power sine of x. But we have what? But negative. So this will be minus. Then stems what? Sine of x. So the p dx is equal to the second derivative. So ladies and gentlemen, the response for exam 15 Roman C means the second derivative dy dx, okay, of the given exponential function, which is e power sine of x, or in other way, it's what? dy dx is equal to what? Is equal to cosine square of x. Then have what? E power sine of x. Then minus what? Sine of x. E power sine of x. Because I want to underline minus sine of x. E power sine of x. Beautiful. This is the final response. So your homework 6, solve example 16, Roman B. Okay? So if that's the case, we still have one question before we go, which is actually is all about parametric function. So we still have example 17, then we leave example. So ladies and gentlemen, let me present to you example 17, which also is concept question. Refer the same book. So refer basic applied book by Tanzania Institute of Education, exercise 9.3, question 4. So the question states that if y is equal to e power 2t and x is equal to 4e power negative 13. Then the question asks us, find what? Find the y dx in terms of t. So this we call the parametric differentiation. So simply because according to the topic we are teaching, which is called exponential and logarithmic function, this we call the parametric exponential function. So we'll be given a function which is in 3 variables: dependent variable y and dependent variable x. And also we have one independent variable, which is t and t. The question now, we have to find the y dx, derivatives of y with respect to x in terms of t. Sometimes even these words of in terms of t is not given. So whenever you find any questions of this type, this we call it in mathematics in parametric functions. So parametric function, we have parametric functions even in coordinate geometry. We have parametric functions in coordinate geometry. So that's why we have to teach you how we can differentiate these functions. So in parametric differentiation, so simply we say that solution. So this, we just write the first, this is what? This is parametric exponential function. This is parametric exponential function. So it's parametric exponential function, the first step, we say that let us find dy dt, where y is given as e power 2t. Okay? So to find dy dt, so differentiate y with respect to t. If you differentiate this, so now you have identified, or you have length terms in some rule. We can let this one, you can let what? So you can let u is equal to 2t, you can find u dt. So let me just teach you a certain behavior or property of this function, or this exponential function. So to find dy this one, simply this is equal to d dt of e power 2t. Treat t as x, as how we've treated x in previous exponential function. So you have let u is equal to e power t, you have let u is equal to t, so let u is equal to 2t. And then now we will have y is equal to e power e. Simply, we used to find the u dt, differentiate this one, is 2, then we have t power 1, this is 1, t power 1 minus 1. If we differentiate this one, dy, with respect to u, this is e power u. Okay? So if you find the u dt, this is equal to what? 2 times 1, t power 0. And also here, if you find dy du, this is equal to e power u, which is e power t. Right? So we usually say that to find dy dt, we use a chain rule, which actually is dy du times what? Du dy. No, dt, du dt. So du dt it is what? Du dt it is e power t, dy du, du dt, excuse me. Okay, dy du dt. So du dt it is 2 times what? Dy du, it is e power t. But simply, you can skip these steps, and you can differentiate a natural exponential function just by inspection. How? Whenever you differentiate e power 2t, you just check the coefficients of t, which is 2. You start to write it as the coefficients of the whole function, not coefficients of this exponent. Then you multiply with the given function, e power 2t. So this is by inspection, so quickly you can differentiate that. Okay? Okay. So this is, remember it is dy dt. So you can let this one as equation 2. So let this to be equation 1. So the second step, let us find what? Dx dt. what is x? So dx dt is equal to d dx of 4e power negative 14, no, power negative 30. E power negative 30. Simply 4 is common, so you can take out of derivative 4 dy. This is d dt, 4d dt of what? Of 4e power negative 30. Be careful because the dependent variable for this function is t, not x. So don't write x instead of t. No, there's not this form. So we can differentiate e power negative 30 just by inspection of 14, inspection of natural exponential function. How? So we say that d dx, you are allowed to let u is equal to or is equal to negative, or v is equal to negative 30, then you differentiate and use the chain rule. That's your quiz. So dx dt, so you see, don't do this mistake that I'm doing. Dx dt is equal to what? Dx dt is equal to 4. So by inspection now. So what the coefficient of exponent is negative 6. So become the coefficients of the whole exponential function. Then multiply by what? There's no negative here. Multiply by what? By the given natural exponential function, which is e power negative 3t. Okay? Negative 3t. So this is equation 3. So we have been asked to find what dy dx in terms of t. So we go into the third step. We said this state, we said that you have to find dy dx. How can you find dy dx for this problem? So dy dx for this problem is equal to what? Is equal to dy dt, it's a quotient, divided by dx dt. Why? Because this will make what? Dy dt, you see, dy dt divided by dx dt. So if you divide, is similar to if you multiply. Dt dot dx. So dt dt will cancel. Remains dy dx. So this is a very important formula. This is the formula we use to differentiate parametric function. Remember, this formula is for parametric function. Parametric function. This formula is for derivative of parametric function. So for this case, what is dy dt? Dy dt, we found dy dt as 2 times e power t. That is dy dt. Then we have dx dt. Dx dt, 4 times negative 3 is negative 12. Then we have e power negative 3t. So you have to simplify. Okay, so the first state, simplify. So this is equation 4. Simplify equation 4. Don't live in this style as advanced secondary students. So dy dx, the first simplification, take 2 divided by negative 12, and that will make 1, negative 1 over 6. And here we have e power t divided by e power negative 3t. So remember the rule of what? Exponential function. If you divide two exponential functions, common base is equal to subtraction. You can subtract its exponent. So you have e power t minus. So here we have our exponential function, which is negative 3 t. So simply this is equal to e power t, negative negative result is positive, 3t, this is e power 4t, power 4t. So here we have what? This is equal to negative 1/6, and here we have negative 1/6. So the answer for this question, we say that therefore dy dx is equal to what? Is equal to negative e power 4t, or negative of what? Over 6. Okay. So if that's the case, that's all about session 6. I would like to say this is the end of session 6. But I have to leave the common homework. Homework 16. So exam 14, 15, 16, 17. No. Okay, so example 6, homework 6D. This will make example 18. So refer. So this will be teaching you to use the book. Refer. Basic applied mathematics, book for Form 5 and 6 by type. Exercise 9.3. Write and solve. Question 5. So this homework, it's a unique homework which will test your level of reading books or using books. Before we end this session, I have a couple of announcements before I end session 6. The first announcement, I would like to invite you into our Tanzania online bookstore, or our Tanzania online advanced library, or Tanzania online advanced bookstore. This is the bunch of the books that you need at the serious pre-form 6 or pre-form 5 or form 5 or form 6 students, or international, even maybe international students, right? So you need this bunch of the books in order to go further in basic applied mathematics. Okay, so you can order all of this material. You can order original scientific calculator. You may order a syllabus that's called the Basic Applied Mathematics Syllabus for Advanced Secondary Education as a student or as a teacher. You may order a reference book that's called the Basic Applied Mathematics for Advanced Level Secondary School Students book from 5 and 6 by Tanzania Institute of Education. You may also order Pure Mathematics 1 and Pure Mathematics 2 by J.K. Backhouse, the reference book. You may also order Basic Applied Mathematics Review Problems and Solutions of 2001 and 2006 in our online bookstore. How can you order all of this material and even other materials? Please send an SMS to us through this telephone number 0759745331. Lastly, in case you feel from your heart that you would like to offer our living God your freeing thanksgiving of any amount, of any Tanzania amount, of any maybe US dollar amounts, of any euro amount, of any amount, even 50 Tanzania shillings, even 100 Tanzania shillings, even 1,000 Tanzania shillings. Don't hesitate yourself. It's your free willing thanksgiving to our Almighty God through this program. And I want to tell you in advance to be used to pay for the running cost of this great national and international project of online teaching or digital teaching. So how can you offer your free thanksgiving of an amount? It's simple. You may use mobile transaction by sending through the telephone number 0759745331. Registered name is Olenjolai. Or you may do the bank transactions. Just read the descriptions below to see the bank account, the bank name, and even for international students, you can also offer through this program by using the bank account. So, my dear students, this is the end of session 6. I would like to invite you to join me in session 7, where I'll be teaching you about integration of exponential function, which actually is a great concept, and many students, they used to find that it's difficult, but I want to tell you, under the grace of God, and because our God is compassionate and love us to understand basic applied mathematics, will help us to learn and comprehend and apply this concept. The challenge I'm leaving to you, please go through this session first time, second times, watch this video 3 times, 4 times, 5 times, and then ask yourself these questions. Where can I use this information to solve a real life problems by using the knowledge I've learned today? So, before we end our today's session, join me in faithful Omega prayer for this session. Our Father who is in heaven, we come before your presence. We say thank you for your greatness, and thank you because you're the creator God. Thank you for what you have taught us. Father, we declare Psalm 136 verse 1 through 3. We give thanks to the God to the gods, because your love endures forever in session 6. We give thanks to the Lord of the Lords, because your love endures to us in session 6 of exponential function and logarithmic function. We give thanks to the God of gods, because your loves endure in us now and forever in Jesus' name. Amen. So may God bless you until we meet the next session. This is Olenjolai from the beautiful country that's called the Kingdom of Heaven, and also from the beautiful physical country that's called the Tanzania. May God bless you until we meet. Stay enjoying the beauty of basic applied mathematics for the rest of your life. See you at the top.
Tuibariki Tanzania, dumisha uhuru na umoja, wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania.